Materials, metals and non-metals. If we look around us, we can see a large number of materials or things of different shapes, sizes and textures. Anything which occupies space and has mass is called matter. For example, book, air, plant and human beings. We can divide matter into pure substances, element and compound and mixture. Element is a substance which cannot be split up into two or more simpler substances by usual chemical methods of applying heat, light and electric energy. Iron, oxygen, magnesium, etc. are examples of elements. Elements can be classified into metals and non-metals. Metals, iron, copper, tin, gold, etc. are metals. In general, metals are hard and shiny in appearance. Non-metals, sulfur, phosphorus, etc. are non-metals. In general, they are not so hard. Most of them have a dull appearance. Physical properties of metals and non-metals. Physical state. Most of the metals are solids at room temperature. Mercury is the only metal known to occur in liquid state in nature. Non-metals are generally solids or gases. Non-metals like sulfur, phosphorus, carbon are solids. Non-metals like hydrogen, oxygen, nitrogen are gaseous. Malleability and brittleness. The property which allows the metals to be hammered into thin sheets or foils is called malleability. Most of the metals are malleable. The property due to which non-metals, if in solid state, break up into pieces on hammering is called brittleness. Malleability and brittleness. Activity 1. To show that metals are malleable and non-metals are brittle. Things needed: small pieces of aluminium, copper, iron, coal, pencil lead, sulfur, a block of iron and a hammer. Method: we take a piece of aluminium metal, place it on a block of iron and beat it. With a hammer, we must take care that we do not hurt our fingers while hammering. We find that the piece of aluminium metal turns into a thin aluminium sheet without breaking at all. Similarly, we observe copper and iron also flatten due to hammering and turn into thin sheets without breaking at all. However, the coal piece, pencil lead and sulfur piece broke into smaller pieces and then formed powder when beaten with a hammer. Conclusion: metals like aluminium, copper and iron can be turned into sheets without breaking when beaten with a hammer. Metals are said to be malleable, whereas non-metals like coal, pencil lead, both are forms of carbon, sulfur, are turned into powder when beaten with a hammer. Non-metals are said to be brittle. Ductility. Most of the metals can be drawn or stretched into thin wires. The property which allows the metals to be drawn into wires is called ductility. Gold and silver are among the best ductile metals. Non-metals are not ductile. Luster. Most metals can be polished and have a shiny surface. This property is called metallic luster. The shiny surface of metals makes them good reflectors of light. Because of their metallic luster, gold, Au, silver, Ag, and platinum, Pt, metals are used for making jewelry and decorative articles. Non-metals cannot be polished like metals. They are dull in appearance. Hardness. Metals are hard due to their ductility and malleability. For example, iron metal is very hard and strong. Due to this, iron metal, in the form of steel, is used in the construction of bridges, railway lines, machines, etc. Non-metals are not hard or strong. They easily break when a large weight is put on them. Only diamond, a form of carbon, is the hardest naturally occurring substance. Conductivity of electricity. To show that metals are good conductors of electricity and non-metals are poor conductors of electricity. Things needed: an electric cell, an electric bulb, a key, connecting wires, copper piece, aluminium piece, iron nail, coal piece, sulfur piece. Method: we make an electric tester by connecting a cell, an electric bulb, a key, and connecting wires to test whether electricity can pass through an object or not. We connect an iron nail in the circuit. We will notice that electric bulb glows. We will notice that the electric bulb also glows in case of materials made of aluminium and copper. We connect a coal piece in the circuit. We notice that the electric bulb does not glow. Similarly, the bulb does not glow in case of sulfur also. Conclusion: metals like iron, copper and aluminium are good conductors of electricity. Non-metals like coal and sulfur are poor conductors of electricity. All the metals are good conductors of electricity. Silver metal is the best conductor of electricity. Sonority: the property of producing a ringing sound by metals when they are struck with a hard material is called sonority. Solid non-metals do not make a ringing sound. Activity 3. To show that metals react with oxygen to form basic oxides. Things needed: magnesium ribbon, sandpaper, a pair of fire tongs, Bunsen burner, boiling tube, water, red litmus solution. Method: we take a small piece of magnesium ribbon and clean it by rubbing its surface with a sandpaper. We hold the magnesium ribbon at one end with a pair of fire tongs and bring its other end over the flame of a Bunsen burner till it catches fire. The magnesium ribbon starts burning with a brilliant white light to form a powdery ash, which is magnesium oxide. We put this magnesium oxide ash in a boiling tube. Add a little water and shake it. We find that magnesium oxide dissolves in water partially. We now add some red litmus solution to the boiling tube and observe the change in color. Observation: we see that red litmus solution turns blue. This shows that magnesium oxide is basic in nature because only basic substances turn red litmus blue. The chemical reactions involved in the above experiment are given as: when magnesium metal burns in air, it combines with the oxygen of air to form magnesium oxide, which is a basic oxide. Magnesium, a metal, plus oxygen from air burns with a dazzling white light to give magnesium oxide, basic oxide. Magnesium oxide dissolves in water partially to form magnesium hydroxide solution, base. Conclusion: metals react with oxygen to form basic oxides. Activity 4. To show that non-metals react with oxygen to form acidic oxides. Things needed: sulfur powder, deflagrating spoon, Bunsen burner, gas jar, red and blue litmus paper. Method: sulfur is a non-metal. We take a small amount of sulfur powder in a deflagrating spoon and heat it over a flame. As soon as sulfur starts burning with a blue flame, we introduce the deflagrating spoon in a gas jar. Sulfur burns in the air of gas jar to form a pungent smelling gas, sulfur dioxide. We keep the gas jar covered with the lid to ensure that the gas produced does not escape. We remove the deflagrating spoon from the gas jar after some time. We add a small quantity of water into the gas jar and quickly replace the lid. We shake the gas jar to dissolve sulfur dioxide gas. We now pour the water having sulfur dioxide gas dissolved in it in a Petri dish. We check the above solution obtained with red and blue litmus paper. We see that the blue litmus paper turns red. This shows that sulfur dioxide gas is acidic in nature because only acidic substances turn blue litmus to red. The chemical reactions involved in this experiment are: when sulfur burns in air, it combines with the oxygen of air to form sulfur dioxide, which is an acidic oxide. Sulfur, non-metal, plus oxygen from air react to give us sulfur dioxide, acidic oxide. Sulfur dioxide dissolves in water to form sulfurous acid solution. Sulfur dioxide, acidic oxide plus water react to form sulfurous acid. This sulfurous acid turns blue litmus red, showing that it is an acid and that sulfur dioxide is acidic in nature. Activity 5. To show that when a metal reacts with water, hydrogen gas is formed. Things needed: a sodium metal piece, filter paper, 250 ml beaker, blue litmus paper, red litmus paper, some water. Method: we know because sodium metal reacts vigorously with oxygen and water, it is therefore stored in kerosene. We cut a small piece of sodium and remove the kerosene by pressing the piece between the folds of a filter paper. We take a 250 ml beaker. Fill half of it with water. Now, put the piece of sodium into the beaker. Observation: the sodium metal floats on the surface of water and at the same time melts to form a silvery white ball. The silvery white ball of sodium darts over the surface of water with a hissing sound, producing tiny bubbles of hydrogen gas. The silvery white ball gradually becomes smaller in size and catches fire. It burns with a golden yellow flame. The solution becomes hot. This is because the heat evolved in the reaction melts the sodium metal and the hydrogen gas produced catches fire. After this reaction, if this solution is tested with blue and red litmus paper, the red litmus paper turns blue. This shows that the solution is basic in nature. The chemical equation involved in this activity is given as sodium plus water reacts to give sodium hydroxide plus hydrogen gas plus heat. Conclusion: when a metal reacts with water, hydrogen gas is formed. Activity 6. To show how metal and non-metals react with dilute acids. Things needed: a magnesium ribbon, aluminium foil, iron nail, copper wire, coal piece, sulfur powder, 6 test tubes, dropper, dilute hydrochloric acid. Matchbox. Method. We take samples of metals like magnesium, ribbon, aluminium, foil, iron, nail, copper, wire, coal, piece, sulfur, powder, in separate test tubes and label them as A, B, C, D, E and F. With the help of a dropper, we add 5 ml of dilute hydrochloric acid to each test tube one by one. We observe the reactions carefully. We bring a burning matchstick near the mouth of each test tube. Observe the burning matchstick carefully. Observation. Reaction of metals and non-metals with acid. Magnesium reacts quite rapidly with dilute hydrochloric acid, forming magnesium chloride and hydrogen gas. Magnesium plus hydrochloric acid dilute react to form magnesium chloride plus hydrogen gas. Aluminium reacts with dilute hydrochloric acid, forming aluminium chloride and hydrogen gas. Aluminium plus hydrochloric acid dilute react to form aluminium chloride plus hydrogen gas. Iron reacts slowly with dilute hydrochloric acid to give iron oxide and hydrogen gas. Iron plus hydrochloric acid dilute react to form iron chloride plus hydrogen gas. Copper does not react with dilute hydrochloric acid at all. Copper plus hydrochloric acid do not react. There is no reaction. Non-metals like coal and sulfur do not react with hydrochloric acid at all. Coal plus hydrochloric acid, no reaction. Sulfur plus hydrochloric acid, no reaction. Conclusion. Reactive metals react with acids and produce hydrogen gas that burns with a pop sound. Less reactive metals like copper, silver and gold do not react with acids. Non-metals also do not react with acids. To show that reactive metals react with solution of bases to form hydrogen gas. Things needed: a test tube, 3 to 4 pellets of sodium hydroxide, plastic spatula, aluminium foil, matchbox. Method. We take a test tube and drop in it 3 to 4 pellets of sodium hydroxide base with a plastic spatula. We add 5 ml of water and shake the test tube containing sodium hydroxide well. We have prepared a fresh solution of sodium hydroxide. To this solution we add a piece of aluminium foil. We can see tiny bubbles of gas in the solution. Observation. We bring a burning matchstick near the mouth of the test tube. The gas catches fire with a pop sound. The pop sound indicates the presence of hydrogen gas. The chemical reaction involved in this activity is aluminium plus sodium hydroxide plus water react to give us sodium aluminate plus hydrogen gas. Conclusion. Reactive metals like sodium, potassium, aluminium react with solution of bases to form hydrogen gas.